Hi everyone, going to do another video for graphing cosine. Going to do it a little bit quicker than we did with the sine, because once you know the basic process, then it works pretty much the same for every trig function, so we'll do it a lot quicker this time. So we're going to graph the basic cosine function. So basic cosine, it starts at 1, and then at intervals of the period over 4, period of cosine is 2 pi, so the period over 4 is pi over 2. So at intervals of the period over 4, it has all of its key points. So it starts at 1, then down to the middle, then down to -1, back to the middle, and then it peaks again as it gets ready to start the cycle over. So once we have that basic cosine graph, we can start graphing more interesting cosine functions. We're going to do 1 plus 1/2 cosine pi x. Well, we'll use Bt+C. One plus 1/2 cosine pi t. Okay, so we can see all the basic properties that this graph has already, right? You can see the 1/2 has flattened the graph vertically by a factor of 1/2. The pi is going to shrink the period to where the period is going to be shorter than the normal cosine graph, and then the +1 here is going to be shifting it up 1 unit. So we can already see those basic properties. The question is, how do we graph it in a nice, precise, accurate way? Let's go ahead and do our period. Period we know is 2 pi over b. b is equal to pi. So the period is 2 units. And then the key points are going to happen at the phase shift plus the period over 4. So let's do our phase shift. So phase shift is obtained by setting the inside equal to 0 and solving for t. So there's our phase shift, that's our quote-unquote starting point, and then here's our period. Okay. So let's take these two values, and we're going to set up those 5 key points. Okay. So phase shift of 0 means our starting point is there at 0, and then the period we know is 2, so the period over 4 is 1/2. So now all we do is from 0, we're just going to add multiple copies of the period over 4. There's 1/2, 1, 3/2, 2. And so by adding multiple copies of the period over 4, we're going to get 1 cycle. And so at this point, all we do, and you're welcome to skip as much of this as you want, because these key points always reappear. It's guaranteed, mathematically guaranteed. We just plug these key points into our function. So f of 0, we get 1 plus 1/2 cosine of 0. And there's that first key point that I had mentioned. Cosine of 0 is 1, so this 1 plus 1/2 gives us 3/2, and that's our first point. If that's 1, 3/2 is at 1.5. Okay. So now we plug in our next key point, which is 1/2. We just get 1/2 pi. So pi over 2. And again, that's that second key point that I told you was going to reappear. Now cosine pi over 2 is 0, so we're left with 1. Now f of the next key point here, 1, cosine of pi. That's that next key point we said was going to appear. Cosine of pi is -1. 1/2 times -1 is -1/2, and 1 plus -1/2 then is 1/2. Plug in 3 halves. I mean, some of you guys can probably see the pattern already. It's going to start here, middle, bottom, middle, and peak. But let's just be sort of mechanical about this, because if you're on an exam, for example, you want to be safe about it. If you have a mechanical process, then you just can rely on that and take the guesswork out of it. So we input 3 halves into here. And there's that same value, 3 pi over 2. Cosine 3 pi over 2 is 0. So this whole term drops. We're just left with 1. So 3 halves, we're left with 1. And f of 2 in for t, and plus 1/2 cosine 2 pi. Cosine 2 pi is 1. 1/2 plus 1 gives us 3 halves. So at 2, there's our y coordinate, and connect the dots. Okay. Then if you want to add on multiple periods, all you do, you just add on multiple copies of the period over 4. Each period over 4 was 1/2 rather. So there's 2.5, that's 5 halves. 3, 7 halves. 4, 9 halves. And you just add on multiple copies of that. And then you're just going to have this same pattern repeating. Peak, middle, bottom, middle, peak, middle, bottom, middle, peak, middle, and so on. Then you just connect the dots, and there's your cosine graph. Okay. To plot the corresponding secant function, all you do is you just replace cosine with secant. So literally the same function, we'll call it g, but a secant function instead of a cosine. So 1 plus 1/2 secant pi t. And now all we do, every midpoint on this graph, we'll just draw a vertical asymptote. So midpoint, midpoint, midpoint. And then we just draw in those secant pieces, the asymptotic U-shaped pieces. Okay, it's going to kiss the graph right here, and then continue off along those asymptotes. If you had the other side here, you'd have a, well, let me just do it. Okay. So there's a cosine and a secant graph.